this video, we're going to solve 3 multiple choice problems related to the production possibility boundary. This question gives us a production possibility boundary where the government's choosing whether to produce search and rescue helicopters or kilometers of highway construction. The first question asks, for the government, the opportunity cost of one search and rescue helicopter is blank, and we're given 5 different options to choose from. The first thing we can really realize is that because the production possibility boundary is flat, so it's a straight line rather than that bow shape that we've seen before, we know the opportunity cost between these two goods is constant. Knowing that the opportunity cost is constant means we can find the opportunity cost at any point along this boundary, and we'll know the answer. So, we want to know the opportunity cost of one search and rescue helicopter. What we can do is look at how much highway we have to give up when we go from 0 to 1 search and rescue helicopter. We see that if we go from 0 to 1 search and rescue helicopters and we're still along this boundary, we've got to move from point F to point E. This results in us losing, getting a little messy, but it results in us losing 50 kilometers of highway construction. So for every search and rescue helicopter we produce, we have to give up 50 kilometers of highway construction. So if we look at our options, we see that B is exactly what we think it should be, so we can fill in B. Moving on to question 2, it reads, for the government, the opportunity cost of 1 kilometer of highway repair is blank, and then we're given 5 different options to choose from. So first of all, let's just clean up our little graph here so it's easier to see. And now we're looking the other way. We're saying, how many search and rescue helicopters do we have to give up to get 1 kilometer of highway repair? This question's a little bit more difficult since we can't just analyze 2 different points along this line to get the answer. We have to do a bit more work than that. We can see from the question and the graph that if the government spent all their $200 million they have for these 2 different projects, if they spent it all on highway repair, they could repair 200 kilometers of highway, so that's point F there. Whereas if the government spent all their budget on search and rescue helicopters, they could produce 4 of them. So what that's telling us is the opportunity cost of 200 kilometers of road is 4 helicopters. However, if we look at question 2, what it's asking is what's the opportunity cost of 1 kilometer of highway repair, not 200. So we need to divide both of these 2 numbers, the one in front of the roadways as well as the helicopters. We can divide them both by 200 to figure out what the opportunity cost of 1 kilometer of road is. So if we divide both those numbers by 200, we're left with the opportunity cost of 1, because 200 over 200 is 1, kilometer of road repair is 1/50th, because 4 divided by 200 is 1/50th, search and rescue helicopters. Rescue helicopters. So looking at the choices that were given for the multiple choice, we see that choice D is 1/50. So we know that's correct. The final question asks, which of the following combinations of kilometers of highway repair and helicopters is unaffordable given the government's budget of $200 million? So to answer this question, we just need to think about the concept of the production possibility boundary. We know that anything along the line, anything along this boundary is efficient. We know that anything inside the boundary is attainable but inefficient, so points A and points B are attainable but not efficient. We're not using all that 200 million. While everything outside of the boundary, now this is getting messy, sorry, is going to be unattainable. And the only point outside is point G, and we can see that point G is one of our options, which is A.